Alright, serious model building number 1. So we'll open up the structure in Qt. So auto calculates maps from MTZs automatically, and RefMac makes MTZs with the right column names for that to be easy. Okay, so what I will do is model build chain A and then copy it to the others. So if we can see already, okay, so this is chain B. We can see difference density, which corresponds to the difference between data and model for the missing loop. So this is the other copy, another copy, and another copy. So which chain is that? That's C, B, A. A is actually the worst of them, so maybe let's build chain B and use that as the master chain. Okay, and we have the pretty sequence. Let's look at that. Okay, so from 32 to 23 to 32 was missing. So that's 23 to there. So that was missing. So let's just mark that. What else is missing in chain B? All the other chains. So from 45 to 54, also missing. So that's 1, 2, 3, 4, 5. To 51, 2, 3, 4. So I know 45 is there, but I'll just mark the region. And I think gap-wise, that's actually it. Okay, the end terminus is not that great. So I think it looks like this methionine sidechain wants to be in this blob, because that would actually be consistent with the secondary structure. I don't like that. Let's just delete it for now. It's not that great. We're at 8, 9. This is actually looking okay. The first. Slightly questionable. This is bad. This is black, red difference density on this side chain. It looks a bit strained. What if we auto fit? Maybe pick rotamers. I think that looks better. Let's have a look at the other chains. Oh, they actually disagree. Okay, let's leave it for now. Going up to 12. I don't think that arginine rotamer is entirely right, but it's good enough for the moment. What residue are we up to? Oh, I'm going backwards again. Residue 10. So Control G. We can go from B14. And space takes me to the next residue. Okay, so I think well, I can see the sidechain slightly out of sync now. Wonder if I refine from there to there, if that will help it. That looks better. I'll leave it for now there. Okay, so we're up to 22. See if that's arginine, that's a little better. Okay, so, oh, we put the crosshair on. So this crosshair has from there to there, the middle to the first tip is 1.5 angstroms, which is roughly a carbon-carbon bond. From the middle to the second line is 2.8 angstroms, which is a hydrogen bond. And from the middle to the outside is 3.8 angstroms, which is the C-alpha distance in proteins. So if we center on a C-alpha here, the next one should be about here. So I can see this C-alpha is in slightly the wrong place, and then the next one is going to be pointing downwards. So I will move this a little bit, and then when I real space refine later, it will snap into the right place. So let's move that there. And then we can do add terminal residue. And we see that that's put the side chain in the right place. That's residue 24. Now I could just add alanines and mutate later, but I see that this is, I'll do it a residue at a time. So this is 21, 22, 23, 24 is threonine. Let's mutate and auto-fit to threonine. Okay, that's not perfectly correct, but we'll fix it. And then the next one is an arginine, so I can see that long side chain coming up there. So again, add terminal residue. There are many ways of building this loop. This is just one of them. Mutate and auto-fit arginine. Okay, this funny, the latest version of Coot seems to not, the real space refinement doesn't connect ends properly, so things float through density, so I think that will be fixed, but it shouldn't, it's not as good as it might be. Alright, so that's 25, next one is arginine, so I can't see, maybe there, so that side chain points out there. Reject, I don't know. Okay, so actually the auto-fitted is better than after it's been refined. Arginine. The next one is another arginine, so I can see there's a big side chain coming up there, so that will just, I'll just add a terminal residue. And let's see where it goes. Where does it go? Possibly into there, so let's mutate it. This is just mutating, and I'll try auto-fit rotamer. Possibly, I think maybe it goes to the left. We'll see later. Yeah, it should be bound to the rest of the structure. I don't know why it's not. Okay, we'll leave it for now. Arginine, and then next to spartate. I think that will be here, this blob of density. Terminal residue. Okay, so that's classic. It's put the side chain. Okay, so there we go. So the side chain is now pointing into the side chain density. So I'll mutate that to aspartate. Okay, so we've built. Let's refine the whole lot. So that looks pretty good. Although now the spartate. Okay, so that's just refining rotamer, so to point it into the density. Aspartate, glycine, serine. So the next residue is small, and then possibly serine. So let's just add. Reject. I can't see. That's not the right place. Let's just leave that for now, and maybe build one residue from the other end. So that 32 glycine. So the next residue up is a serine. So there's the glycine. Accept serine, and that is. Maybe I'll try building it as a loop. So this one should be serine. So let's just mutate it. So I now need to fit into here. From here to here a glycine and a serine, so that's residue 29 and 30, so let's do fit loop. Fit loop Ramachandran search, chain B. Residue numbers inclusive is 29 to 30, 2 sequence glycine serine. Chain B, fit. Okay, that is a terrible mess. I would normally have expected better from Coot. Let's just try real space refining over the length of it and see if it snaps into place. Okay, pretty good, except this is now a cis peptide, which is almost certainly wrong. If I delete this aspartate and then add it back, that will probably fix it. Okay, accept simple mutate to aspartate. Let's real space refine again. Much better. So this is not by any means perfect, but it will look better. Yeah, Coot seems to have lost the ability to properly account for the ends of the regions it's refining. I think this is going to have to be fixed, because you see it's introducing breaks and it shouldn't be. I think hopefully the refinement will fix this. Let's regularize geometry and see what that does. No, it's not. Okay, let's just add that leucine. See if we refine across the gap. That will fix it. No, not really. Regularize geometry. That 3-enene is in the wrong place. Let's add back 3-enene. See, it should understand that these bits link together. I don't quite know what's wrong with it. Okay, and that's looking good. There's no cues to show that my peptide geometry is twisted. So now this loop is actually not looking too bad, so I can put that into green. Oh, that's a horrible green. Okay, so the other one was 55 or 54. Let's save this. Back to Coot 0. 54. Alright, so I have to build this loop. So this goes. That's 54M, so I need to go back GTV, or from the other end, so that's 45. 44. This doesn't look quite good enough for... This is not good enough for the Coot loop building, and also this density actually looks tricky to build into, so we might not build all of it. Let's just build backwards a residue or two. So this is MGTV, so M, add terminal residue, mutate to glycine. I think I'll just leave it there actually. Rotamer analysis. So we were building chain B. This is the bit we've built. Auto fit rotamer. So again, you can do this in a very automated way, but I'm deliberately just being a bit more manual than usual. Autofit rotamer. Autofit rotamer. Autofit rotamer. Have to be careful with arginine, it has many, didn't like that, let's undo it. So that's not rotameric, but it fits the density. Here's another arginine, it's probably a better way of fitting that, yes, that looks better. Okay, oh, and look at this, that's definitely wrong, that needs to go into this long blob of density. There we go. How does that look in the others? Similar. Ah, you see it is different in this chain. Very annoying. Okay, but I think chain B is still more right than the others, so I'll copy NCS chain B. And if we look at the bit that we have built, so 25 in chain B, this loop, oh, it hasn't copied that, why? I guess sequence mismatches. Let's just try again. BNCS chain B. No. Well, the sequences between the chains must be too different for Michoux. I don't quite understand why it's not doing that. Okay, never mind. This will improve our density. Nevertheless, when we do the refinement, and let's just draw the sequence. Okay, so we can see we've built in the bits for chain B. Let's try copying a range. So where's that? That's residue 30. B23 to B33. Let's copy those residue. Copy a residue range. B 23, 33. Okay, so that's chain B, and chain A. We now see the loop is there copied from chain B, so we can see this arginine. So it doesn't fit into density very well, but the refinement will put it in place. That's O. This is the other chain. This one possibly might have to delete it from there, but I will, in fact, let's delete this range now. Okay, so delete that from chain D. Okay, let's save this. And now run a third RefMac job. In a minute after this one, I should probably move to Phoenix Refine, which I understand a little better, and I like the control it gives you. Right, so that's our model building we just did, RefMac 3, use NCS restraints, the default 20 cycles, so going. This will take about 5 minutes, and then we can have a look and see how it looks. So the RefMac job is finished. Let's have a look at the log file. So our R3 has gone from 41% all the way to 36%. So another 5% R3 drop, which is excellent. So when we look at the map again, it should look even better. So let's have a look. RefMac 3. Okay, so our difference map should start to become informative and directly show us things that can be built. So here we see a long tube of difference density corresponding to the missing loop in chain A. This is the chain I couldn't build in chain, the loop I couldn't build in chain B. This is another long bit coming out of the end of chain B at the C terminus, so I can build a few more residues there. Here is the same thing on chain A. This is part of this same long tube of difference density. Don't know what that is. I think the side chain should be here, so this main chain is in the wrong place. It should be over to the left, but it's moved into the wrong place. So let's have a look at that loop that we built, which was about residue 25 on chain B. B25. So we started off about 23. That rotamer looks wrong. There we go. And then 25, 26. So this was empty space, and now actually this loop looks pretty good. Not perfect, but pretty good. This side chain is also clearly in the wrong place. There we go. Right, so we're ready for the next round of model building. Hopefully try to fill in that other longer gap at residue 45 to 55.